My name is Jasmin. I'm a web developer, mostly working with React. And in the past few months, I've been looking into SolidJS in my free time. And during that time, I learned a lot about Solid itself and also how reactivity in web frameworks works and what the challenges are there are and so on. And in this talk, I want to share my experiences, introduce you to SolidJS. I'm not sure, has anyone worked with SolidJS before, created a project or something like that? Yen? And who has heard of SolidJS before today? Okay, a few. Nice. Okay, first I want to take a step back and look at what problem reactivity is trying to solve when it comes to web frameworks. So let's say I have a variable called meetup location, and I want to display this variable in my web page, in this example, in my heading element. So what I would do is I create my heading element, and then every time I'm changing my meetup location variable, I need to make sure to keep this heading element text in sync. So every time I change it, for example, here to cyan, I have to call .textContent again and update my heading element. And this is, of course, very tedious and in large code bases even impossible to do without introducing bugs or without just producing a complete mess of code. And this is if broken down, this is exactly what reactivity solves when it comes to web frameworks. In my example here, I want every dependent of my meetup location variable to automatically change, to react and update itself, basically. And let me check. Yes. And in the past, web frameworks have had different ways of dealing with this issue. For example, Svelte uses a compiler to make your variables you define reactive. Vue uses something similar to SolidJS, which I'm going to get into a bit later. And for example, React has a very component-bound reactivity and state management where it just reruns everything and gives the hard part to the virtual DOM. And yeah, so there are many different ways to deal with this. And what I want to show you a bit more in detail is fine-grained reactivity. And fine-grained reactivity can be accomplished by only three parts. One, the most important part, basically, is our observable state. In SolidJS, we call these signals. And what we want is that every time a signal changes, it should notify so-called computed values. And computed values are things which depend on our observable state, which then, in another step, trigger side effects. And side effects can be basically everything from updating the DOM, from saving something in the local storage, or changing search query parameters in your URL. So basically everything. And now I'm going to introduce you to SolidJS, and I'm going to show you what Solid provides us to accomplish this. So I have this example prepared. Give me a second. Where I wanted to keep it close to my previous example. And I already mentioned that in SolidJS you have signals, and to use these signals, SolidJS provides us this create signal function, which is just a function which takes a default value, in this case novu, and provides us with a getter function, so-called accessor, and a setter function to change or update our signal. If you're familiar with React, this will look very familiar to you, but in the background, it's nothing alike like React. And I'm going to show this later. And down here, I'm creating my h1 element. I'm changing the text content. And something important here is you notice that I have to call my variable. I can't just put meetup location in here because the accessor is a function, and this is very important. And here I change my meetup location, and here I have to set the text content again, which is not what we want. We want to make the heading element change automatically or reactively when we change our meetup location. And for this, Solid introduces another function to us called create effect. And I just noticed that it's very hard to code live in front of people. So yeah, please bear with me if I'm a bit slow. But what create effect does is yes, it takes a function where you can do almost everything in there, and it becomes reactive. So you don't see how the heading changes. So let's introduce a console log here. Meetup location. Let's format this code. And here you see that this create effect function is called twice. And when you're coming from React, this is also familiar to you, but you know that in React, you have something additional here, which is called a dependency array. So in React, you would put this meetup location in here, so React actually knows that we want to rerun our effect when the meetup location changes. But in Solid, we don't need this. Solid is aware of its dependencies, and you don't have to do any additional work. And this is one of the key features of Solid. And how this works is what I'm going to show you in the next part. I actually forgot something. It's important to know that you don't have to call your signal directly in this function. The dependency awareness, let's call it that way, is everywhere. So basically what you can do is define a upper function. Let's just console log. No, let's put this code in here and then return our meetup location, which we do to uppercase. And now in here, we can call upper, and it's still working. So even though I have my signal access inside another function inside create effect, so anywhere in the code, it still works. And now I'm going to show you how this works. This part of my talk is going to be a bit technical, so please bear with me. But I think if you understand this, this will be, or it's very beneficial. At least for me, it gave me some sort of insight I haven't had before when it comes to reactivity. And you can also use this knowledge in other web frameworks. Okay. I hope you can, yeah, I think you can read it. Yeah. If not, I have a problem because I can't easily fix that. Okay. If completely simple, wait a minute, I'm missing a slide. Okay. This will still work. If completely simplified, our create signal function is just a function which takes a value. In our example before, this was novo, and it defines two additional functions called a getter function and a setter function. In the getter function, please ignore this code. It returns a value so you can get the value. And in the setter function, it accepts a new value and updates the value. And now to add reactivity to this, we need to know what depends on us. So which effects are actually listening to us. And for this, every signal has a subscriber set where all the currently active effects or listeners are in. And when the get function gets called, we search for our listener, which is the current effect, and then we add it to our subscriber list. So later on, when the signal change, we can notify this effect again. And this is what's happening in the setter function. Every time the signal updates, it loops through all of the subscribers and calls its effect function again. And now I'm going to show the other side, which is the create effect side. And here we first need a global effects array, which includes all the current effects which are running. And we introduce a helper function called getCurrentEffect, which just returns the latest effect function in the effects array. Yes. And now our create effect function works like this. We wrap the whole first. The create effect function accepts a function we want to call, like you saw in the previous, like in this example. That function is exactly this part. And what we now do in the effect is first we add ourselves to the effects array, which indicates that we are currently running. Then we call the function the user provided to us, and afterwards we remove ourselves again. And with this code, which is like 50 lines of code, we just build our own signal. Of course, in a real web framework, there are some additional things, like you have to clean up dependencies and so on. But this code, just like this, actually works. And so let's run through that again. We first, let me show our code again, just for reference. Like we have our create signal function here, we have our getter and setter here, and we access the getter function inside of our effect. And this is basically what signals to this effect that we want to listen to it, just by calling it. And yes. So what we first, so when we define a create effect function, it gets run for one time. This is like the init function, where it adds itself to the effects array, then calls the function the user provided to us, and in that function we access a signal, which then now can check the effects array and get the effect. And I know I'm saying effect a lot of times. I hope you can follow me. And then we will add this effect to our subscribers list. So every signal has its own subscribers list, which it can use to then call the effect again. So it's basically a loop, if you could say so. So you call the effect function for the first time, and the signal changes later on, the effects function gets called again and gets added to the subscriber list again, and so on. And yes, that was it. I'm not, if you have a very complex question, please ask it at the end of the talk. But if you have a small understanding question, please ask now. Okay. So let's continue. Exactly. So let's go through this again. What SolidJS achieves is reactivity with no virtual DOM, with no dependency arrays, and with no compiler. So you might see that this can be very efficient, and it is. And what I'm going to show you now is some way to easier write code, because no one wants to actually write front-end code like this. We're way past that now. So what SolidJS uses is JSX. SolidJS decided to use JSX because it's easy to write. It already has a big ecosystem around it because of React. But please don't confuse SolidJS JSX with React JSX, because it's completely different. It uses the same syntax, but in the background it has its own compiler, and it's not working like React. Yes. Okay, so I've modified my example code a bit, where I introduced a button which changes my meetup location signal. And as you can see, this works. But the code with create element and so on is still the same. So let's convert this to JSX. So with our button, we can just basically write inline HTML. And yes. And then we can put our method in here. And now we already have a code which is a lot more readable than before. And now the H1 element is a bit more different because it uses a reactive state inside its text content. And you might think that you have to do something difficult with create effect or so. But what SolidJS does is the following. Yes. Oh. You can write this H1 element just like that, and it's still reactive. Why? Because even though SolidJS doesn't use a compiler when it comes to reactivity, it has to compile the JSX. And during that part, it checks the JSX for any state which gets used. And in this example, our meetup location gets used. So it wraps just this part. Nice. It wraps this exact text part in an effect in the background. So we have this fine-grained reactivity I mentioned before. And you can actually observe this. If you go to the Chrome DevTool Inspector, you see that here we have our reactive variable and so, and if I change it, did you see how only Novo/sign flashed? This is because only that part actually updated. The entire other DOM just stayed like that. And that's not because a virtual DOM catches our updates or something. It's just how signals work. And that's really powerful and performant. Yes. Okay. And now I want to introduce you components. Again, you might be familiar with components when you've worked with React before, but there are some differences here. First, I changed the example to count so I can show so I can show you the reactive part a bit easier. And here I have a very similar setup where I have the h1 element displaying the count and a button which increases the counter when clicked on. And what a component is when it comes to Solid is just a function. Down here I have a render function which is basically a helper function from SolidJS, which allows me to pass a function which returns JSX and append it to any HTML element. So yeah, if you set up a SolidJS project, this is already in the most root file. So yeah, and now because it's just a function, we can do something like this app. And do you see how this app printed out in the console? And even though the state changes, the app doesn't get printed again. In React, you would see app flashing like 5 times or 6 times. But in SolidJS, a function is just a way to group code for you. It doesn't add any overhead. So it could even set interval here and put this function, this in here. And you would see the count increase. And I can help it increase here. But the set interval is only called once, because the function is only called once. It's just a function. Yes, and I want to show you something additional. Let's rename this to counter. Call this one app. Nope. Return. So, and counter. And now I have 2 separate counters. Wow. But the interesting part comes now. Because we defined our signal inside the function, it's scoped to the function. You know that. When you define a variable in JavaScript in a function, it can only be used inside this exact function. Of course, unless you use var, but let's not talk about that. And now, if we want to make both counters use the same state, I messed it up. We can just move the state outside of this function. And now, both functions use the same state. This is because in SolidJS, state isn't bound to component, unless in React. I know I'm very sorry for mentioning React that many times, but it's just what I'm most familiar with besides Solid. So I hope who has used React before, or at least has some knowledge about it. Okay, that's good. I should have asked this before the talk, but I'm very happy with this. Okay. Yes, that's it for this. So again, solid components do not hold state, do not add overhead, and are just functions for you to group code. So it's basically a utility for you and not a utility for the web framework to manage state. Or yeah, and you also in React, you actually, okay, you shouldn't have to worry, but in React, every component adds some sort of overhead. You can't just create a million components. But in Solid, it doesn't add any overhead. And that's really cool, I think. Okay, no, not yet. Okay, and I have another example for you, which also introduces a few popovers to a few other web frameworks. So who has used Vue before? I think a few of you. Perfect. Who used Svelte before? That's great. Nice. Okay. A bit more a complex. Let me. Nope. Please don't. Okay. So let me first explain this example. I have a attendees component here, which gets appended to this app. That's actually generated code. Ignore that. It just adds the attendees to my DOM. And in the attendees component, I have an array of attendees. And I list this array in two different ways. First, I call my signal and directly call map on it. Just the default array map function. And for every attendee, I render this text element, which lists the name of the attendee. And down here, I have a so-called control flow component from SolidJS. And first, because Solid doesn't use a virtual DOM, we have to be a bit aware of how and where we use signals. Because when a signal changes, everything in that part re-renders. So I'm going to show you that in a bit. And the for component is like a wrapper for an array. It takes a property, an array, in this case the attendees, and gives us a render function for every entry in that array. And I added this show render class to every text element, which is just a animation, so we can actually see what element gets rendered. And so let me just, if I refresh this here, you see every element show in blue. And now let me just go to the attendees list and, for example, pick add. Great name to type. Add. And now watch what happens to our lists. Let me do that again. I hope that's right. Yes. When this property gets added, what map does is basically re-render everything, because we are calling our signal right here. So this entire part gets re-rendered. And we don't want that. We only want the actual entities to update which actually changed or got added. And for this, Solid provides us this for component, which makes sure to only add an element to the end in this case. And if you're coming from other web framework, which you are, you might be familiar with keys when it comes to rendering lists. And this is exactly what's happening here. The for component uses the value of the attendee as the key, so it knows which element to re-render. And okay, let me think. There is also, you might know that, are you familiar with indexed rendering or indexed key, or basically non-keyed rendering? Okay, let me show you. So there is also this other way for rendering lists, which is called non-keyed rendering or index-based rendering. And what this is index, exactly. So let's see what index-based rendering, list rendering actually does. So let's add again. It does the same. Nice. It actually doesn't the same. Let's move our new value we want to add to the start. Let's do that again. Why did the last element flash in the index list? And this is because when we the index component uses the index of every property in our array to know when it should re-render. So in our case, every element changed its position. So every element got re-rendered, but we didn't see it because it basically hijacked the element under it. So this is actually because, and this is why we only saw the last element flash, because for this element, it had to create another element. And it's not perfectly, I hope you understand it. I'm not that, yeah, okay. So let's look at how index non-keyed list rendering flashes down here. So let's add another name. Sorry for being that lame and only using 2 names. So now look closely at every name. Boom. Every name flashed. And down here, for Yuma, only the P tag flashed. And this is because every name basically got moved down an element. And for the last element, for the last name, there wasn't an element yet, so it created a new one. And this is actually bad. It's more performant. So you might know from React, this linter warning map without using a key. This is exactly that. Because React, if you don't provide a key, it uses non-keyed, which is that non-keyed rendering. And you might think, why is this bad? It actually edits the already existing element. So this should be more performant, right? Yes. But it comes with some downside. Let me show it. Here I have another example which compares keyed versus non-keyed lists. So I have the same example. I have a few names, and let's put every name besides it in this input. And what you see here is every attendee is for every attendee, we list the name and the input besides it. The input isn't controlled or anything, it's just a plain HTML input. And now let's add a name. This isn't what we expected. The for component correctly added an element to the start. So every input stayed the same. It didn't move down, it stayed the same. And here, for the indexed or non-keyed rendering, every name got edited and moved down, but the input stayed the same. So if you have complex code with some component state, using index-based rendering isn't good. Which is why I got very confused when I saw that Vue actually uses indexed rendering per default. It doesn't warn you that you don't provide a key. I think it's because they don't want to explain keys to you. But I think the React approach is a bit better to warn you about this. I mean, of course, most of the time this isn't an issue, but I'd say this should be default, or you should, it should be best practice to just key your lists. And Svelte, wait. Svelte also uses indexed and non-keyed rendering per default. So please be aware of this, that you can provide a key to Svelte, and if you don't, it just uses index-based rendering. If in React, here it explains the keys in the list, that a key should just be a number or a string which uniquely identifies your object. So it knows where to move it if the array changes. And you might be wondering, why in SolidJS you don't have to provide a key. Why? Because the Solid creator thought that it would be better to just handle this internally and provide you this indexed component if you still want to use indexed keyed rendering. But the for component actually looks at the reference of the properties. So it knows, because of the reference, when to re-render. You might be wondering, if I change a variable in an object, it doesn't change the reference. Yes, you're right, but I think this goes a bit too deep for this talk. So if you want to know about this, we can talk about this later. But when dealing with objects in SolidJS, it gets a bit tricky, and not just because of that. Yes, and one last thing I wanted to show you is this page. Are you familiar with this page? Who already was on this page? Okay, only one person. Okay, then it's not that cool that I show you this. But I'm not showing this page because of Solid's performance. We know it's great, but what it's just like this aha moment for me, because I saw this page linked at so many places, and all the time I thought, why is it called keyed results and non-keyed results? And that's exactly because of this. Non-keyed results are using indexes as the key and are allowed to reuse elements. And this is why most of the time here, non-keyed are faster, but in practice, it's not that great to use them. So Solid didn't even provide any benchmarks to this. It's only up here. But yeah, Preact too. I think Preact is missing down here too. Yeah. Yes, I think that's it. Okay, one last thing. I don't know if you know Dominic Gunaway. He is currently working at Vercel, I think, but he works at Svelte at the moment. And before, I think he worked at React, actually. Yeah. So he is one of the big names. And he posted this in August, I think, where he mentioned that he thinks signals are this important to include them in the ECMAScript spec. So he's working together with these names. I only know Ryan. Ryan Carniato is the creator of SolidJS. He is great. Yeah, he's just great. He does many talks. He streams almost every Friday for 5 hours. It's just like godlike material if you want to get into how web frameworks work. He's like the web framework guy. He knows every web framework because he's very interested in it, and he compares everything. He wants to, and this is probably also why SolidJS is how it is today, because he knows that much. And of course, SolidJS has this fortile of being late to the game. It's a very new framework, so Solid can just look at every mistake, react it, and make it better. And other frameworks, of course. And yeah, I suggest you give SolidJS a try. Even though it's new, it already has a solid ecosystem, I'd say. Had to make that joke. And yeah, it also has its own meta framework for server-side rendering called Solid Start. It's still in beta, but it's getting there. So Ryan has big plans for it. And it's of course not only Ryan. He has a few people working with him on this. And yeah, I'm really looking forward on how this part of the web framework ecosystem evolves. So yes, that's it for my talk. Thank you for listening. Thank you for being here. Thank you.